Whether it's the notes in staff notation essentially being coordinates, the fact of climaxes being situated in most pieces around the point of golden ratio, or Mozart making a note of mathematical equations in his compositions. Music and mathematics are inseparable. Can we establish any relationship between mathematics and a guitar? Let's see. We begin with basic arithmetic. We can calculate the note of any given fret of a guitar just by adding its number and its string value, and then substituting it by the values given in this chart. The Fibonacci sequence. The Fibonacci series of numbers is 0, 1, 1, 2, 3, 5, 8 and so on. But if we look at the most common chords used in a guitar, they are composed of notes of these values for a given scale. Ratio. The Greek philosopher Pythagoras, by experiment, found out that if a string was halved in length, its pitch increased by an octave. Similarly, a string of 2/3 length increased the pitch by 4 notes. One of 3/4 length increased the pitch by 3 notes. These ratios form the basics of music theory. Exponents. When finding the differences between the pitch of different notes, in the chromatic scale that is, an interesting pattern is observed. Taking the first note as 2 to the power 0 units, the next note would be 2 to the power 1 by 12 units. The subsequent one 2 to the power 2 by 12 units, ad infinitum. Now let's come to the practical applications of maths in a guitar. Mensuration. It has been observed that the area of the sound hole as well as the volume of the sound box of a guitar impacts the loudness and the richness of the sound produced by allowing more air molecules to vibrate. The rule of 18. To determine the accurate locations of frets while making a guitar, the rule of 18 or 17.817 is used. The first fret is placed 1/18th the distance away from the top. The next one 1/18th of the remaining distance until the desired number of frets are obtained. By doing this, it puts the fret an octave higher exactly at the center of the string. This also gives us a complex yet useful formula. Distance of x equals s divided by 2 to the power x by 12. X is the number of the fret, s is the length of the string, and the distance is that from the bottom end of the string to the fret. Angles. The tuning keys have to be rotated by a certain number of degrees to change the pitch of a string. These angles may be as large as 720 degrees or as small as 90 degrees. But even the slightest change can make discernible differences in pitch. Curves. Finally, the bracing is a very important structure while assembling guitars, as it will greatly affect the quality of sound. Bracings with a steeper curve produce crisper sounds, and vice versa. This is just a glance of the beauty of mathematics and how deeply rooted it is in the world of music. Thank you.